Hi, everybody. This is Paul Speciale. I'm the Chief Marketing Officer of Scality. And today is our next iteration of our podcast, where I'm joined by my colleague, Giorgio Regni, who's the CTO and founder of the company. Hi, Giorgio.
Hi, Paul. Hi, everybody.
Hello. Great to talk again. And as usual, we're looking for very interesting and timely topics. And certainly for the storage industry, one of the things that we see is this rapid evolution of disk densities. It's something that people that follow data storage have known for years, right? We saw kind of this doubling in disk densities over the last decade, but it seems to not be slowing down. And Giorgio, you were recently on a panel with a number of other companies, including Western Digital. On that panel, I think they shared some data about what their roadmap foresees for increasing disk density. So maybe that's something we can start with at the top.
Yeah.
You were there, so maybe you can give us some comments of what
Yeah.
you.
And when we mean drives are getting bigger, we talk both about flash and hard drives, right? Because software defined, we can use either technology. As you can see here, that's the roadmap from Western Digital. Kioxia was also on the panel. They had a similar high density roadmap for flash. And you can see that the goal is to more than double from now to 2034 the density
Amazing.
on a drive, and multiple platters, maybe bigger form factors as well. And so Hammer Plus, we are right now we are doing Hammer tech.
Right.
Hammer HDMR 3D will be coming as well. So you can look at 100 petabyte systems with close to hundreds of terabyte drives or more.
Yeah, it's simply amazing to me. When we started this, 15 years ago, I think we were dealing with drives that were a terabyte. And now we're certainly dealing with HDDs that are over 20. But if you look at this, the trend is simply amazing.
One of the first deployment, I think we had less than a terabyte drives.
Yeah, yeah.
The older 2.5 inches, not even 3.
I remember those
25.
very well. In fact, we had then at the time 2U servers with 24 drives that were maybe 20 terabytes.
Yeah.
So
But we
that's
go a long way. And I remember 15K drives where we had to optimize and use the center of a drive for performance and,
amazing.
and leave for
So you
higher
get faster speed.
throughput. Yeah.
Yeah, makes total sense. Yeah.
Mm.
Well, so it's interesting. And now to see it continuing for this decade, 10x, they're talking about between 2018 and 2034. You and I looked in the news and we do see some specific examples now of a few vendors that are putting
So
out some
looking
really
on the
huge
flash
ones.
side, you want to comment on these?
Yeah. I'd like to first mention that Solidigm is a vendor certainly leading in this arena. They have already on the market a 122 terabyte SSD drive. It's a very dense, very power efficient drive. It's optimized for read intensive type operations, but also very power efficient. So it's one of the ones that certainly is on the market making a mark. But then you spotted this other one from SanDisk.
Yeah, 256 terabyte. I need to spend more time on the spec sheet, on the data sheet of this one. I think there's some trade-off in terms of performance, trade-off in terms of latency as well.
Right.
But it's going to be interesting. And as a software-defined system, we don't want to optimize too much for a certain drive, but you still don't want to use it the best you can. So there's always some variation into how we have to do things to make use of these high-density systems.
Yeah, makes sense. And obviously there's TLC, there's QLC. So these seem to be the kind of technologies that are making the most dense drives. All right. So with that said, it all sounds great, right? We get more capacity, we get more density, but there has to be a challenge or a trade-off in all of this, right? So for us and vendors creating data storage systems, can we talk a little bit about what the challenges are as these drives
Yeah,
scale?
so when we talk in general, it's all about durability. When you store data in an object storage system, you expect to be able to get it forever. The way we design system, by we I talk the industry, not just Scality, you look at it as unit of failures and how much you want to protect against these failures. Disk is one unit of failure, whether flash or magnetic. A server, rack, data center, multiple countries if you do some sophisticated multi-geo. When a drive becomes 100 terabyte, this wasn't designed. None of the system were designed for a drive being that big. We talked about less than a terabyte in the past.
I remember the day we thought about erasure coding 15 years ago was because the drives were already getting bigger, but not this big, right?
And so there's challenges around how do you detect failure? Because, we have to scrub drives, to detect latent sector errors.
Right.
If it's that big, scrubbing is going to take a long time, right?
Mm.
Now, if you need to copy data from a flash drive because for some reason maybe it didn't fail because of the media itself, but it failed because you did an upgrade to the OS and the OS doesn't understand that drive anymore. There's all kind of combination of things that happen in real production. Now you have to copy, recreate, or go to a replica for hundreds of terabytes at a time.
Yeah. Sounds time consuming.
Yeah. When we do the math on the durability of a platform, we look at 24 hours as the time we have to rebuild a missing drive.
Yeah.
And 100 terabyte on a 100 gigabit network. If you consider there's traffic in production, so you don't have all the bandwidth for you, you have to share with the incoming traffic. This could take more than a day.
Yeah.
And now you impact durability on that system.
Clearly, customers don't want to take the system down or make it unavailable when this is happening. So you're right. You have to trade off the bandwidth.
Yeah. And people think about catastrophic failures. We don't really see that as much. I'm talking about operation issues like, somehow somebody went into that drive and tried to do some kind of optimization, but it's offline because of what they did. So now you have 100 terabyte to, you want to show no problem to the applications. You want to hide all bad issues. So now you have to reroute traffic, rebuild, recreate parities all in the background.
Yeah. And you have this comment here about new durability algorithms, right? So
when we're faced with this in the, maybe it was 5-6 years ago, we started designing local parities as a way to have some protection locally and the ability to recreate data locally, even if it's not as much protection as the network protection, still having local parities to be able to rebuild the maximum you can without having to go through the network, especially important in multi-geo situations.
So it keeps the repair local.
I
get it. So you mentioned these constraints around server, disk, rack level, locality. Can you comment a little bit about that and what the impact is?
Yeah, and I think that's something that people don't really realize. When you hear from a storage solution that it does multiple copies, it's not enough. They have to be respecting some constraint. So if you do 5 copies of your data, you want it on 5 different disks, right? But if you have more than one system, you want it on 5 different servers. If you have more than one server, or at least 2 different servers. Maybe you want it at least 2 on different racks, or maybe you want at least 2 on different data centers. And all these constraints have to be respected even after you start getting failures. And so in a lot of object storage system that we know, this actually doesn't work. So you have the constraint, maybe not that fine-grained, but at least servers and disk. And if in the event of disk loss or server loss, it could be that when you replicate the data, you're not respecting this anymore. And you may have 2 copies of the same object on the same server, which you do not want. So some of the things we've patented at Scality in the past is how we distribute the servers and data so that we can satisfy the constraint up to many failures. So you could lose, for example, 4 drives on the entire system and still guarantee that there's a copy on a different drive. Or you could lose 4 servers and still guarantee there's a copy on a different server.
I get it. I visited a data center once and it was clear that power feeds were going rack by rack. So you almost have to consider the rack.
Yeah, it's an actual unit. All data centers have zones in them. Rooms, whatever we call them. So it's another placement constraint you have to respect as well.
I get it. Okay, it's very interesting, and I know that we have some algorithms in place to sort of assure this happens. Can you maybe give our listeners a little bit of insight into how we do it?
Yeah, so we have a patent on the data placement and how we calculate the position of servers and object. Scality works in a keyspace system, where it's a virtual address space where each file or object has an address, and that maps to where they are and where the replicas are in our system. So if you go to the next slide.
Sure.
It's a very simple view, vintage Scality logo. So
early era.
Yeah, early on. So you see it's a simple key space from 00 to 99. And then I have server 0, 20, 40, 60, 80. And if I store the object 11 and I want 2 copies, we don't want to go to a central database to know where the copies are. So what we do is we project on this triangle inside the circle. So 11 becomes 44, and that's my replica, and 44 becomes 77, and that's my replica number 2. So if I know the object key, I know all the replica keys, I just have to do some math, and that's very fast, and I don't have to go to a database, and that's one of the key properties of a system.
Very clever, kind of a geometric projection.
Yeah. Kind of, we had a circle, we want to make the most use out of it.
Right, I get it. Okay, so what about practically?
So if you had only 4 nodes, right? The naive way is you give each of the nodes the same portion of a key space, 25%, and that's this diagram, right? We have 4 nodes, they each get a piece of that key space, and that's balanced because we all get the same percentage.
Okay, get it.
This doesn't work. Like if I do 4 copies and I lose node number 0, there's no way I can have 4 copies on front, or I can respect the constraint anymore.
Right, I understand. Yeah, so you need to think about how to divide it.
So what we do is we create virtual instance of the nodes, and 6 or 12. So this example has only 3, just so that we can visually see it. So yellow is a node, the same node. Purple is the same node. Orange is the same node. So we arrange it so that all the projection fall on a different machine.
Got it. Okay.
So if you were to do 3 copies and lose a node, a server, you would lose all the nodes from that server, so the 3 instances, but you will still get the replicas, each of them on a different machine, even after a server loss.
So they survive. I understand. Okay. When I started here with the company, I understood this and I saw some fantastic visualizations of how you guys do the key space. I guess this can get very advanced, right?
Yeah. And so we have a tool that generates key space because they can be very advanced. We also have default key space for most situations. And so this example, I'm not going to try to go in details, but if we were to do 4 copies on servers of different size, so now we're going to allocate different portion of the key space depending on the capacity of the server. That means you can grow the system with the nodes of different sizes, as opposed to have to grow with the exact same size. And that's a key because the drives keep getting bigger. So eventually you're going to add much more dense systems. So we're going to take more portion of the key space. And the algorithm does the same thing we talked about, but now it's on a spiral to make it kind of easier to follow. And if you look at any gradient in that, right in the spiral, it's always going to be 4 different colors.
I
to guarantee that there will be a copy on a different physical machine.
It's intuitively very understandable. I understand it's super complex. I'm going to come back to you in a different episode and maybe drill down more on some of these sophisticated
And so we have tools to calculate this key space, and there's 2 of them, and one is supposed to be better than the other, but actually we always use both.
Okay.
But it's kind of interesting use of Monte Carlo and a little bit of probably AI in the future.
Yeah, very cool. It's super practical, right? Because as we talk to customers, they're thinking 10-year, 20-year type deployments. And of course the servers are going to change, right? So you're going to need this different density.
Bigger, faster CPU, bigger flash drives, everything changes. And so this system can account for any change.
Yeah, and keep the system up and running while you're growing and everything else. So that's really great.
This also allows you to upgrade servers. So if you want to remove a machine and add another machine, and you want to disturb as little as possible, that's things that we can calculate as well.
Okay, so durability while adhering to constraints, multiple simultaneous cascading failures, and growth without disruption.
And growth and evolution over time.
Impressive. All right, thanks for the quick overview into that. And again, as I said, we probably come back and drill down into some of these topics a little bit more. Thanks, Giorgio. Just to conclude, then, I wanted to give the viewers a few links here. There was a presentation, as we referenced, by Western Digital at the Supermicro Open Summit, Open Storage Summit, to be precise. Here's the link if you're interested in seeing that presentation about how they see the disk drive roadmaps growing. The patent you explained, Giorgio, is available online for those that are interested in the underpinnings. And then I provided a few links here if people are interested in more of the design principles. I actually found a video of you from a few years ago presenting the key space and our design principles at a Tech Live event. So super interesting if you want to go back and see that. There is a tool that also lets you see how these key spaces are visualized here on this link. And then for those of you interested in more practical information about our own object store product, Scality Ring, it's here for you. Okay, so with that, thanks, Giorgio. I appreciate your time and the explanation, and we'll see you next time.
Thank you. My pleasure.
Thank you.